Okay, so on the front, or on the first page, we made a parabola that was opening right or left down here, so it was opening right and left. In this one up here, so I drew one that's opening up and down. So I drew the second one. If y squared is first, that's the positive term, and the x squared term is negative, then that means your parabola, or sorry, your hyperbola is going to open up and down. So remember, you make this rectangle or this box around here based on the square root of these numbers. So in other words, if y squared is over a squared, the distance from the center out to this edge is the length of a. So the square root of a squared, right? And we have to go plus and minus a, so we go up a and we go down a. Then, if you have b squared, you take the square root of b squared, you go right and left. So from the center out to this edge is b. Now, what is the length of c? Well, c is from the center up to a foci. And remember, the foci are then going to be on the y-axis up here. So the foci are going to be 0 plus or minus c. On this one, it would be plus or minus c, comma, 0. So then if we look at this bullet point, it says the difference between the focal radii is 2a. So the difference between the focal radii is 2a. The difference between the focal radii is 2a. Well, I can see from here to here, this is 2a. Why does that make sense? The difference between the focal radii is 2a. That's why I stopped this here. Remember, the difference is we take P1, F2 minus this. So if we take this entire length, and we subtract this from it. In other words, we're just subtracting this part. So this is the difference, which is, if we put the center here, that's going to be A and A. So yes, that makes sense, right? A point on here, you have this whole entire from here to here, here to here. Well, we subtract that over here, and we get just this focal radii, which is the difference, and that's 2A. So you have to memorize that. So I've gone through this. The final thing we need to look at is the relationship between A, B, and C. If you recall, in an ellipse, it was b squared equals a squared minus c squared. Now, why is that? Well, in an ellipse, you had your b, which was your minor axis. This was your b. You had your a, which was your major axis, and then you had your c, which was from the center to the foci. So what was the longest part here? It was your major axis, because the foci were on the inside of the ellipse. So C is smaller than A. But in a hyperbola, C is on the outside. So this distance from here to here is bigger than this distance. So this time we have to reverse the C squared and the A squared. So B squared equals C squared minus A squared. Also, you could just put a diagonal right here. A squared plus b squared equals c squared. There's your Pythagorean theorem, right? We could rearrange that. A squared plus b squared equals c squared. Okay, but that's not true for the ellipse, so be careful. So maybe just memorize it's b squared equals a squared minus c squared for an ellipse, and c squared minus a squared for a hyperbola. But I want that to make sense in your brain, because in an ellipse, a is the longest part, c is shorter because the foci are on the inside. In a hyperbola, C is the longest part because the foci are above and below the length of A. Okay, and then these asymptotes, hopefully you understand this. The asymptotes in this case are going to be rise over run. Well, this is my rise this time. It's A over B, right? So if my asymptotes are horizontal, right and left, it's going to be B over A. If my hyperbola opens up and down, it's a vertical hyperbola, then it's A over B. Again, you shouldn't have to memorize that. That should come to you naturally once you make the rectangle and you put all the pieces together. So I'm hoping that is the goal here in the end. So you can read this paragraph on your own, but I'm going to jump right into these examples. So the first step you want to do is to make your hyperbola look like this. So these, you're not going to be able to do anything until you make them have an equal to 1 on the right-hand side. So this one's done. So the first thing we do is we draw, the next thing we do is we draw our axes. Remember, we're always going to be centered at the origin, so put your origin in the center of any graph that's given to you. Then we're going to count out the square root underneath the x, 1, 2, 3, so I put a point here, 1, 2, 3, put a point there. And then we have our square root of 16, so 1, 2, 3, 4, 1, 2, 3, 4. And the whole reason I'm doing that is to create a box that's going to help us establish our asymptotes. So create your box immediately and then create your asymptotes. So my yellow lines, I'm putting them in yellow because they're not part of the graph technically. It's just to help guide us with how to sketch the graph. And it also helps us get information if we need to, if I ask you for asymptotes, you should now be able to get it. What are my asymptotes? They're plus or minus rise over run. My rise is 4, my run is 3. There we have it. We actually already graphed this on the front of the page, but we can practice again. Okay, because the x squared quantity is first, that means my vertices go here and here. So I just make a horizontal hyperbola and it opens right and left. And there we have it. We're done. Nothing else to do. Okay, the second one. I'm going to move my 81 to the other side. But when I move my 81 to the other side, it becomes negative. Okay, that's okay, we can handle that, except now we have to divide everything by negative 81, which then makes what happen here? It makes my signs get reversed. So now my y squared is in front, because that's a positive, and my x squared is second. Okay, so be careful there. Now I'm going to draw my axes. Okay, so my y goes up and down 9. So 2, 4, 6, 8, 9. There we go. 2, 4, 6, 8, 9. There we go. My x goes right and left 3. 2, 4. So here's 3, 2, 4. Here's 3. I have to count by 2s because that's the only way I can make it work. Now I'm going to make my rectangle. Right, so I have to go all the way out here. And then I'm going to make my asymptotes, make them go through the corners of this rectangle and through the center. And then my last step is to say, does it open up and down or right and left? Well, because my y squared is first, it has to open up and down. So there we have it. Done. Next one, we're going to divide everything by 2 because we have to have a 1 over here on the right-hand side. So we get x squared divided by 1 minus y squared divided by 2 equals 1. Okay, I'm going to draw my x and y axes. A little off there, that's okay. X and y axes. So for my x, I go right and left 1. For my y, I go up and down square root of 2. So you're approximating. Do the square root of 2 in your calculator and then approximate that on your graph. Right, so what is the square root of 2? And then you approximate that on your graph. Then you make your box going around. Why are we doing that? So then we can do my asymptotes. And then I look and I say, well, my x squared quantity is first, therefore I'm going to open my parabola, or sorry, my hyperbola, excuse me, right and left. We are done. So that should be down here. Right and left 1 should be right down here, sorry. My x-axis is a little off. Okay, so what didn't I do? I didn't find the coordinates of the foci. How am I going to find the coordinates of the foci? Well, we're going to have to use this equation right here, which says b squared equals c squared minus a squared. What is b in this case? B is 16. B squared is 16. Sorry, 16 equals, well, c squared we don't know, but a squared is 9. So we add 9 to both sides, c squared equals 25. So what is c? C is plus and minus 5. So my foci are out here at 5, 0, and over here at negative 5, 0. So find the coordinates of the foci. The coordinates of the foci are plus or minus 5, 0 for this first one. For my second one, my foci should be on the y-axis. Okay, so here for my second one, my b squared is 9. 9 equals c squared minus a squared, sorry. C squared minus 81. I move that over, I get 90. C squared equals 90. So what do we get? We get 0 plus or minus 3 root 10. right? We take the square root of 90 on both sides. Square root of 90 is 3 root 10, so it's plus or minus 3 root 10. So we'd go up and down that amount. And then finally over here, we're going to do b squared. Well, my b is 2, right? So I get 2 equals c squared minus a squared. So what does c squared equal? It equals 3, sorry. So what does c equal? It equals plus or minus the square root of 3, comma, 0. Why is it x first? Because it's on the x-axis, because my parabola, or my hyperbola, sorry, opened right and left. Okay, moving on, next page. Find an equation of each hyperbola described. So I know my foci are at 0, 4, and 0, negative 4, which instantly tells me that c squared is 16, because 4 squared is 16. I know the difference of the focal radii is 2. Well, remember on the front it says that that equation, the difference of the focal radii is 2a, therefore a equals 1. Therefore a squared equals 1. Put it in my formula. I get 16 equals c squared, which is, we don't know, minus 1. So I add 1 to both sides, and I get c squared equals to 17. So then my equation needs to be something minus something equals 1. I need an x squared and a y squared. My a squared always goes in front. My b squared goes here. Oops, I see my mistake. This should be, oops, my 16, so this should be a 15. My fault, people. So c squared is 16, but this should be 16, so 16 minus 1 is b squared. B squared is 15. So my b squared has to be 15, my a squared has to be 1. But what goes first, the x squared or the y squared? Well, because your foci are on the y-axis, that means that's your major axis. That goes first, and your x squared goes second. So it ends up being y squared over 1 minus x squared over 15 equals 1. Okay, pause and try the rest on your own, and then I'll quickly be going through them, or you can just check the answers because we're running out of time. Okay, the final three. The next one says my foci is negative 8 and 8. I square the 8, I get 64. That means my distance c squared is equal to 64. Difference of focal radii is 12, therefore a equals 6, so a squared is 6. I plug it into b squared equals c squared minus a squared to get b squared is 28. Remember, you don't need to take the square root because we put a squared and b squared under these. Why is my x squared quantity first? Because my foci are on the x-axis. Therefore, this is my major axis, or it opens horizontally. So x squared over 36 minus y squared over 28 equals 1. Down below, I did everything based on the asymptote information, right? And so if I look at the asymptotes, I know the rise is 5 and the run is 3. That means my y-axis has to be paired with 25, my x-axis has to be paired with 9. The last thing I have to do is decide which one goes first, the x squared or the y squared. Again, because my foci are located as x, they're written as x-intercepts, that means that it has to be a horizontal hyperbola. So it opens right and left. So it's x squared over 9 minus y squared over 25 equals 1. Again, you might need to pause, re-listen to that if you're not understanding. Maybe pause now that you've seen that and try this last one. Remember, your asymptotes are rise over run. Your rise has to be associated with your y coordinate. Your run has to be associated with your x coordinate. So that means when you're making your rectangle, you go up root 2 and to the right and left 3, which means my a squared or b squared, one of them is 2 and one of them is 9. How do I know that my a squared is 2? Or sorry, my a squared is 2, my b squared is 9. How do I know that? Because my foci are in my y value, which means it has to open up and down. And so therefore, my y squared has to come first. It has to be with this major axis, which is 2. My x squared comes second. That's associated with my b squared, which is 9. So y squared over 2 minus x squared over 9 equals 1. And there you have it. And I will see you during Friday's class to review, or to do all the hyperbola problems, and you can ask me questions then. Tuesday's review, next week Thursday is the test. See you soon.